Chapter 22, we look at derivatives of logs and power functions. To find the slope function, i.e. the derivative for this, we want y prime. The derivative of e to the x is just e to the x. So the first term gives us 2e to the x. The second term, we're going to have to use the chain rule. The derivative of e to the negative 3x is e to the negative 3x times the derivative of negative 3x, which is negative 3. So we have 2e to the x minus 3e to the negative 3x as our derivative. To find the position and nature of all turning points, we need to look at where the derivative is 0. And in this situation, we're going to want to use the product rule. First term times the derivative of the second. So the derivative of e to the negative x is e to the negative x times negative 1 plus the second times the derivative of the first. And now both terms have e to the negative x. I can factor that out. And I get negative x plus 2. I'm distributing the negative in. And then plus 1. The turning points occur where the derivative is equal to 0. A power function, e to the negative x, can never be 0. So the only option I have is that negative x plus 3 would be 0. So x equals 3 is where the turning point is going to occur. The question is it a maximum or is it a minimum? And if we plug a number like 0 into this power function, into this derivative, we get that the left side of 3 is positive, meaning the function is increasing. If we plug 4 back into the derivative, a number to the right of 3, we get a negative value, which means the function is decreasing, which makes whatever point is at 3 a maximum. We now have to figure out what y would be. So we're going to plug 3 back into this original function. So we have a maximum at this point. To find the derivative of something other than e to the x, it's a little bit different, and we're going to derive this derivative right now. What we're first going to do is write this as a natural log, or using a natural log. So we can rewrite this as y equals e to the natural log of a to the x, because the e and the natural log would cancel out. And that is equal to e to the x natural log of a. And this is something we can differentiate. We know that the derivative of e to something is just e to that. And now we're going to use the chain rule. Natural log of a is just a number. So we have natural log of a, which is just a constant, times x, so we have natural log a. And this first piece, that was equal to a to the x. This derivative is also in your formula packet. So we're going to find this intersection algebraically, meaning without using our graphing calculator. Since they're both y equals, we can set them equal. and then get it equal to 0. I'm going to write e to the negative x as over e to the x. Now I'll multiply the whole thing by e to the x to clear out that fraction, and I get e to the x squared minus 4 times e to the x plus 3 equals 0. This is a factorable quadratic. E to the x minus 3 times e to the x minus 1, that equals 0. So e to the x needs to equal 3, or e to the x needs to equal 1. We can take the natural log of both of these, and we get that x is equal to the natural log of 3, or the natural log of 1, which is 0. So we get 2 intersection points for these graphs, one of them being 0, -2, plugging in 0 into the first equation here. The second point is natural log 3, 0. E to the natural log 3 is just 3, minus 3 is 0. So there's our 2 intersection points. Here we want to differentiate with respect to x. So this looks big and nasty, and oh my gosh, we're going to use the chain rule, and we'll need the quotient rule in doing that, but we really don't need to because of properties of logs. We can rewrite this equation as y equals natural log x squared minus natural log x plus 2 times x minus 3. And yet again, y equals 2 natural log x minus natural log x plus 2 plus natural log x minus 3. Now we differentiate. Natural log of x, the derivative of that is 1 over x, so the first term becomes 2 over x, minus natural log x plus 2, the derivative of that is going to be 1 over x plus 2, times the derivative of x plus 2, that's the chain rule, which is just 1, and then minus 1 over x minus 3. There's our derivative. Not as bad as it looked at the beginning.